All right, I got a little bit cut off in the last video, so I'm going to go over that one more time real quick. Again, the asymptote is what it approaches. It approaches 0, but it never actually hits 0. Okay, so that's our asymptote, y equals 0. Now, example 3. A ringtone company charges $15 a month plus 2 for each ringtone download. Create a graph and then determine the key features. So, very quickly here, I'm going to keep it in the first quadrant because I already know it can't be negative. All right, so we've got y equals $2 per ringtone plus 15 for your monthly fee. So the y-axis is going to be cost, and the x-axis is going to be the number of ringtones you download. Okay, number of ringtones. So 1, 2, 3, 4, 5, 6. That should be enough to get an idea of what's going on. We'll count by threes here. Well, let's count by twos. This is 1 by 2. So 2, 4, 6, 8, 10, 12, 14, 15. We need to go a little higher. Okay, 2, 4, 6. All right, that should be enough to give me the idea here. So 0, 15 is where we're going to start. Okay, and then at 1, we're going to go up 2. So basically, I'm going to go up 16, 17 over 1. And then 18, 19 over 1. And that's enough for me to get the idea. So we're going to talk about the key features. So the first one we're going to talk about, I always start with domain and range. So my domain has got to start at 0. So 0, I should say, can you really include the lines in between here since what we're doing is ringtones, right? No, you can't. It's going to keep going forever and ever, but you can't really include the points in between because you can't download a partial ringtone. So my domain is all whole numbers. Okay. I would give you credit if you said x is greater than or equal to 0, or if you said 0, positive infinity. But you do need to be aware that really you're in this problem, you're only talking about whole numbers. All right. So your range is y is greater than or equal to 15. Okay. You're telling me that 15 is the lowest point you have. It would be worth pointing out that you could write it as the list of numbers 15, 17, 19, ... Okay? Because it keeps going on forever and ever, depending on how many ringtones you download. All right? So, it's linear. It's increasing. Okay? And again, for now, that's enough because it's always increasing. Like, we'll have to do some interval stuff later, but you can say it's increasing when x is greater than or equal to 0. Okay, basically from 0 to positive infinity. Okay, these are the same thing. Okay, these are just different ways of writing the same thing here. Okay, all right. So decreasing, I'm going to skip it for now because it's not, so it'll be none. So where is it positive? Okay, first off, it's always positive. So it's positive when x is greater than or equal to 0, or again from 0 to infinity. Okay, it's always positive, and since 0 is included, I should use the bracket in both of these places since we're including 0 to get that notation correct. All right, let's see what else we have. Do we have an x-intercept? So we got no x-intercept, and our y-intercept is 0, 15, which also happens to be, and I'm going to write it here, that also happens to be a relative minimum. Okay, and then we don't have a asymptote, obviously, because it's linear. So I'm trying to think if there's anything I missed. I think we about covered it all. Okay, you see how this works, guys? You're going to have to graph some of these and list out all key features. I'll make sure to go over, if there's any questions about the Walsh, what key features you're looking for. but I think it's going to be pretty clearly defined, especially if you go back and watch these videos. But yeah, basically key features are just being able to describe what's happening in a graph or to a function. Okay?